I don't even care what type of system you put in. As long as it has a dehumidifier, you're set up for success. You can have a great designed system and a great manufacturer, and if it's installed poorly, it's going to perform poorly.
That the VRF has been cheaper than a American Standard,
Really?
which is kind of surprising.
Yeah.
You know, the classic is you have a track home, 2-story home, and then there's one unit for upstairs and downstairs. It's always a disaster. There's always a hot spot, and you can never get it right, no matter what you do.
Hey everyone, thanks for watching this episode of the In the House podcast. We got a great talk today. So what we're going to talk about, right now there's a lot of different manufacturers and systems and components, in regards to HVAC. So, you have things like, you have a traditional system, you have VRFs, you have geothermal, you got, water to air, I think is starting to make a comeback. You got ERVs and DHUs and zone dampers and all these things, and it's like we're going to cut through some of the noise today and really get down to what makes a great system, right? So, especially for Texas, we're going to get into what makes a great system for this climate. We're going to talk about specific equipment, what's great and what is just wasteful, what's unnecessary. And then also, you brought this up, and I think this is a good thing to talk about, is makeup air. That seems to be forgotten about in a lot of construction, residential projects. So we're going to talk about some strategies as it comes to makeup air. But before we get into that, Michael, you got a headline you want to talk about?
Yes, sir. I've got two today, actually.
Oh, what? Two?
First one, this is more of a shout out, but the Design Awards for the AIA was in May 2026. And there's just some fantastic projects going on out there, and I just wanted to highlight that one in particular. We can post the website link on our show notes, but go take a look. It's worth a look. There's tons of great projects. I'm guessing actually you guys probably worked on a few of them, if I had to guess.
I would say at least one or two.
Probably, It's a good chance of that. My favorite is called the Clarksville Residence. It's actually the personal home of Michael Shue, who's an architect here in town.
I'm a fan of Michael Shue.
And he does fantastic work.
He's awesome.
And I just looking through it the other day and the website, and I was just really impressed with the level of work that's going on here in town, and so many great architects and designers. You know what? I don't remember off the top of my head.
We can post it. No, I want to give him a shout out to whoever built that. I think I know which one you're talking about. Yeah, it's gorgeous, man.
Fantastic house.
Great. What's your second?
Second headline is this is a financial headline, believe it or not. This next week, or within this next week, I believe actually it's tomorrow, is the SpaceX IPO.
Oh, yeah, nice.
And that it's supposed to be it's making news across a lot of different news outlets because it's supposed to be one of the largest of all time,
right?
But, actually, the largest of all time.
Yeah.
Why do we care about that? Well, there is a potential for there to be a significant amount of centimillionaires, people who make hundreds of millions of dollars to fill in for people out of that event. And SpaceX has a giant warehouse facility that manufactures chips here in town, amongst other things. And so I imagine that will affect the residential industry here in Central Texas in the next couple of years.
Yeah, probably bring a lot of clients our way.
I would imagine so.
I where there's money, there's definitely homes.
It's interesting. You look at Austin, you think about like the Dellionaires, for example. Dell. Yeah. Back in the early 2000s, late 90s. But I'm not going to say those are exactly those are 100% similar situations, but there are a lot of similarities, and a lot of amazing projects and work came out of that time period too. So maybe here in the next couple of years we'll see some pretty cool projects.
I sure hope you're right. I mean, it seems like it. I mean, the amount of growth and just industry that company alone has brought here is really just incredible.
It's amazing.
And Austin is booming. I mean,
booming.
I think I read the other day that Georgetown is actually the fastest growing community in the United States.
It's wild.
In the United States, dude.
Yeah.
That's just north of Austin.
Yeah.
And it's exploding right now. I mean, where they're bringing tons of people into Texas and into the Austin suburbs. I mean, it's really incredible. I mean, there's some growing pains with that.
Oh, 100%.
A lot of changes.
It's not the whole market too. You read like housing in Austin this last year, what market-wise was down, right? People were losing value on their homes. But again, the homes that we're talking about here, there's tiers to that, right?
Sure.
And, some of the projects that we work on are kind of those once in a lifetime type of projects.
That's true. Those are the ones you can't talk about, unfortunately.
Yeah, exactly.
You might
mystery projects.
You might get assassinated.
Yeah.
Unfortunately. Well, that's awesome.
If you don't see me next episode, you'll know what happened to everybody.
Yeah, right.
Yeah, I have a feeling. Tell, thanks for coming, man. You literally just came here from a job.
Yep.
But you still got your tool belt on and everything.
Let's go.
That's just how it goes during this summer. Just everybody wants you when you're an AC guy. So
you just gear up for the summer.
Oh yeah,
You're
definitely.
gonna get all the calls.
Everybody's hot.
Your service team is busy.
Oh yeah, definitely. Yeah, even the install guys. So it just doesn't stop here. Just with the growth you were talking about.
Okay, tell us real quickly what company you work for. What's your role there?
So I work for RITE by Design. I got a lot of different hats. I'm the owner's son, so I kind of do it all. I do install, service. I'll be in the office, just anywhere that I need to fill in. That's where I'll be. So I've really touched all aspects of it. And been in it a long time.
Right.
Well, that's one of the reasons we wanted to bring you on, because we'll touch on a variety of different topics here, but you've seen a lot of different pieces of that and kind of understand the big picture, quote unquote. You're not just installing a system and walking away. You also understand that, well, in 5 years, you guys are still going to be working on that house.
And that's always
tune-ups and the whole thing.
Huge part that and installer doesn't always see that, and then you've always got a trim guy that's not seeing what the installer has to go through. So being able to be in both worlds is always really nice when it comes to finishing these projects and servicing them over the years.
And you have a background in electrical engineering, is that right?
Yeah, so whenever I was younger, I would go out in the field with Dad. Didn't really ever want to do it.
Yeah.
Went to school, kind of fell into electrical engineering. That's a whole other story, but graduated.
How do you fall into electrical engineering?
So I started going to Texas State. I went for physical therapy. I thought that's what I wanted to do, but it was boring. The grades weren't great. I was playing rugby and then decided to quit.
I split my lip in half playing rugby.
Oh, really?
Yeah,
nice.
I was playing intramural rugby at the Air Force Academy.
Oh, wow.
And some guy's head basically to the nose and to the lip, just cut it right in half. I was worried my teeth were going to fall out.
That's crazy. Yeah, I split open my head and had to get a blood sub.
Yeah, man, it's rough.
Super fun sport, though. But so I was doing that. Grades weren't going great. Decided to switch to some kind of engineering. And at the time, Texas State only had 3 different engineering degrees. And so I decided to go with electrical. It just seemed like the best one.
Yeah.
And so just kind of really learned to love it. But
that's cool.
But as I went on, just talking to all my different, all of my peers and everything, they were like, "Oh, you've already got a business set up, man. Like that seems like the way to go." And just kind of kept getting pushed more that way. And then I graduated in the middle of the pandemic, and so it was just like,
you're like, options are
options are very limited. So I'll work for Dad and just see how it goes, and it's been there for 5 years now.
Fantastic.
Full time. Got married, had a kid, so we're in for the long haul.
Come
now.
on,
man.
So,
well,
that's awesome.
I think it's going to turn out to be a valuable thing. I mean, the systems are only going to get more complex, especially from an electrical viewpoint.
Well, and the thing was always, well, why did you have to go to school, right? But it's like, being able to have that engineering experience and, problem solve and be able to think through things logically and be able to get to a decent conclusion, going through all of that may have been overkill, but it definitely helps in
100%.
in the end. So
yeah, you sit there and think something through. I mean, we've been in some situations. You and I, we're doing some serious, physics calculations on some of these wires, going stuff, and Tel's actually doing the, doing the equation. I'm going, yeah, this is above my head.
Yeah, right? That's insane.
A lot of fluid dynamics with air and everything, and so just understanding those principles always really helps, even though you're not down in the weeds, but knowing just kind of higher level how that works too, and really understanding definitely helps in some situations. So, but anyway, so
what's our first topic for today?
Well, really, our first topic is just there's lots of different options out there. Right. I mean, I printed this out, and I don't want to go specifically into each brand, and we'll show this. We'll put this up on the screen, but I printed this off, and this is just a chart just showing all the different brands of, HVAC companies out there.
And there's a ton of them.
And there's a ton. and some of them's like, I never even heard of a lot of these, and, it shows the brand and then their parent companies. And so, we do, most of our homes are, I would say they're designed by a mechanical engineer. So we get the design, we send it off to you guys and have you bid on how to install it, right? So, but those are like really nice high-end systems most of the time. So what I want to really get to, I want to get your thoughts on, what just makes us a solid system? Like what's just baseline in this hot, humid climate? If you were to build a house and put a system in it, right, what would you do? And what would you consider this is baseline, this is what you need, and then how do we tune it up from there and make it just top of the line system?
So, I guess you kind of got to start with how the structure is. Are we dealing with foam? Are we not? I would say just for the sake of argument, we're dealing with a foamed house, right?
Right.
I would go with a heat pump system for one, not use gas. I mean, not that there's anything wrong with using a furnace. They have nice 90% furnaces now, but that's it. They're 90% efficient during heating season, right?
Okay.
So, going with heat pump is what I always advocate for. It's just, you just don't have to worry about some kind of gas leak or anything like that, even though,
and the ventilation and all that,
and ventilation and stuff. And so it's just like, it just kind of makes it simple.
Yeah.
Again, not that there's anything wrong with a furnace. It's just I would push
I
somebody
like
towards a heat
gas,
pump.
and I always thought gas was more efficient than a heat pump. Is that not the case?
That's not the case. Well, especially now, there's been a lot of improvements with heat pumps too. We're really experience with Mitsubishi, and their whole thing is efficiency and trying to move away from gas. Like they don't even sell a furnace.
Wow.
So I mean, but again, not that having a furnace is bad.
Yeah.
It's just I would push you towards a heat pump. I just think it makes everything a lot more simple.
Yeah. Okay.
Really. So there's that heat pump. Now, as far as like VRF or like a traditional system goes, I would push you towards a VRF. It's just more efficient.
What are we looking at cost wise though between like a VRF system and a traditional?
Well,
system?
so we do train American Standard for our like traditional brand, and then we have Mitsubishi. We've been finding that the VRF has been cheaper than a American Standard unit. Yeah, for the whole system, which is kind of surprising.
Yeah.
But with all the price increases and stuff, that can always change.
It's
there's not like a huge gap where like the VRF system is just way more at this point. I mean,
that's interesting.
Also, depending on the series you go with Mitsubishi, there's tiers within Mitsubishi as well. And there's certain they call them series. Certain series were made for different things.
Yeah.
So, just for efficiency's sake, especially if you're going to have this foamed house, you've already put in all this work to make the envelope nice and the structure, tight. And so I would just go with a heat pump VRF. I mean, just to quote Mitsubishi, like their hyperheat, I mean, I don't totally know the numbers off the top of my head, but they're like 100% efficient down to like -10 degrees.
Wow.
Whereas like a traditional heat pump, it'll start losing efficiency at like 32.
Wow.
Okay.
So that's just kind of the difference there. Now, so that's your actual
That's crazy.
AC and heat.
Yeah.
If you can, describe maybe for people who don't know, what a VRF, what does that mean?
Sure.
And versus a traditional system, like what are some of the differences between how these systems work?
Yeah, that's a good question.
So back in the day, a traditional system was just one speed. It was on or off.
Yep.
So there was no varying. And then it became 2 speeds. So then it would be half capacity and then full. Now what they've started doing is traditional systems will have multi-speed. So it's not infinite between 0 and 100. There's like set speeds, but it can choose more than just 2.
Okay.
VRF is technically infinite. It can go anywhere from 0 to 100 and anywhere in between there, and it'll vary the indoor and the outdoor.
Wow.
So that's where all the efficiency gains come from.
But that's not just fan speed or blower speed is what you're talking about, right?
I'm talking about compressor speed and blower speed
Okay.
on the indoor. So like they'll work in tandem depending on all the information that it's getting.
That's crazy.
From like the outside air, from the indoor temperature. I mean, there's like all these sensors and everything that it goes through, and it has an algorithm and it sets itself. So yeah, so kind of what we're dealing with heat pumps now is multi-speed and then VRF.
That's some electrical engineering right there.
Yeah, buddy.
Yeah, definitely. And so that's the big differences between the two. So as far as the AC goes, having that heat pump and if you can VRF, I think is great. I think it's just better and it's just easier for people to understand. And work with.
And I want to try to put it, and I want to dumb it down a little bit more, for my brain to understand, just based on my reading up on like what a VRF is. So a traditional system is, like you said, it's basically on or off. It gets a signal from the thermostat, it kicks on, and now it's pulling in air and cooling it down and sending it back. And the way I understand it, a VRF is like it ramps up the flow of the refrigerant, right? So if you need more cooling, it uses more refrigerant. If you need a little bit of cooling, it uses less refrigerant, right? Is that?
I mean, that's a really good way to think about it. It's like as it ramps up, it's going through its cycle faster, right? It's just pulling more of that heat out and then dumping it out into the outside air, right?
Okay.
When we're talking about cooling.
Right.
So it's just like a big old heat sink, right? And as it ramps up, it just makes that cycle faster.
I see.
Is really all that happens.
Okay. Cool. Well, okay. So you're all for the VRF, which I mean, I think VRFs are great, honestly, and I'm kind of on those same lines. I think if I were to do a new build and I get to pick my system, I'd probably pick a VRF as well. I mean, they seem great.
Yeah. I mean, people have been really happy about them, and happy for us means that we don't hear about it. If we don't hear from our customers, then everything's working because nobody thinks about it. They just look at the stat and they go, "Okay, we're happy."
Right.
So, we just have really happy customers that have VRFs, and so I guess I would say the only thing about them though is that it's especially like the foreign or Asian ones is like with Mitsubishi for a long time, especially after the pandemic, is that getting parts is really tough.
True.
And so, the good and bad thing about Mitsubishi is that they make all of their parts in-house, whereas like American Standard like kind of contracts out some of their parts and they're more universal. And so and so whenever you're choosing, like maintenance is always a huge part of it too.
That's true.
Because these are moving systems. It's not like you buy a countertop and you don't ever have to, I'm sure there's more to it than I know, but it's with moving parts, they are going to fail.
Yeah.
And so thinking about that
it's only a matter of time.
Right. Yeah. Thinking about that future service is always a big part too. So.
Yeah. And the other thing with VRFs is there's a little bit more flexibility as far as having different zones on one system, because like a traditional system, you have a big box, it's pumping out a lot of cooled air, and you're basically, if you want to control, 3 different bedrooms off of one unit, you're basically opening and closing dampers in order to, hey, this room needs more cold air here, or this needs less over here. So you're just opening and closing shutters, but this thing just ramps up and turns on 100% no matter what the demand is.
That's it.
Whereas a VRF, if this bedroom A over here needs cooling and bedroom B, it needs heating, it can kind of handle both of those demands at the same time without interrupting one room over the other. Is that right?
Zoning can be great. Like you're saying, it's very easy to have a bad zone design overall. Especially if you can't handle capacity changes.
Right.
Being able to a third your capacity run is definitely huge. So
okay, let's dive into that real quick.
Okay.
Let's talk about zoning for a minute. In this, what are some of your pet peeves whenever you get plans from a mechanical engineer, you're doing an install or something, because I've seen kind of a couple different ways that houses can be zoned, especially some of these larger homes. Do you have any things that you kind of insist on, or when you see something you're like, oh gosh, this is in terms of the zoning, how it's kind of set up?
Yeah.
Well, and so we can talk about two different kinds of zonings, right? We can talk about one unit being zoned, right? And so there's a lot of pet peeves there. Like the classic is you have a track home, two-story home, and then there's one unit for upstairs and downstairs. It's always a disaster from my experience. There's always a hot spot and you can never get it right, even no matter what you do. So as far as zoning a single system, that's really the big one. Now zoning with refrigerant, like splitting up a house, the tendency is, since these VRF systems can handle more than one indoor on one outdoor,
right,
is that how people pair things. And so one of the big ones that we always run into and insist on people not doing is pairing something with the primary. So because so with these, with every brand, every system, coils fail. And so you have a leak, the system doesn't work, it doesn't cool, it doesn't heat. And so if you have something paired with that primary, like let's say it's the kitchen, and the kitchen coil fails, well, now the primary doesn't have any cooling or heat either. And so, the kind of what we get trained and what we've experienced is like, always keep the owner of the house happy, right? So it's like whatever you can do to
wherever
keep them by themselves, do it. And so that there's less fail points, right? So it's just like, that's always one of the big ones, is put the master or the primary by itself, and then trying to, one of the big things is just because you can doesn't mean you should.
Yeah.
Right.
I've heard that before.
And so engineers, so like, we've had engineers where these systems can handle 8 indoor units on one outdoor, and you've got all these different failure points, and we're looking and we go, oh no, this isn't good.
This is gonna be bad. Yeah.
Right. There's like eight different points now to where we'll have to go to try to find a potential problem. So
that's a headache.
So as far as zoning goes, those are like the really big ones.
Yeah.
But a well-designed zone system, I think, is great.
Right.
Just as long as all the thought is put into it, and it's split up correctly.
So I'm glad you brought that up, because I have a project right now that's it's designed as a zoned system, and I kept hearing people talk about how crappy a zone system was, and I'm looking at the design, and I'm no expert, granted, but I'm looking at it, it's like, man, this really doesn't seem that bad. It seems like it's split up into, there's I think 5 different units just on this house, and so it seems to be zoned really well. Right, so you're not trying to like run feed a kitchen and a bedroom on the same unit, right? So things are split up really, really well.
That's great.
Yeah. It's like all the bedrooms are on their own unit, the master's on its own unit. Like it's split up really well. The zones seem fine, and it's like, man, this is going to be a well-built, well-sealed, insulated home. I was like, I don't see any problems with it. I get it that it's not flashy and like new VRF, like cool stuff.
Right.
But it's like, man, if it works, it works. Like, why rock the boat,
Well, and so that's a really good point, and that's kind of what everything boils down to as well. Is just like, just as long as it's done well, it should work, right? You know, kind of, with all these different options you have, like they're options for a reason, right?
Yeah.
Like they have worked.
Yeah.
It just depends on how it's done. So,
and a lot of it boils down to the installer. I mean, you can have a great designed system and a great manufacturer, and if it's installed poorly, it's going to perform poorly.
That's it.
And then the owner's going to think, well, this is a crappy system. It's like, well, no, it's just, Joe Schmo over here didn't do a good job.
Right. There's a little more thought that needs to be put into it.
But conversely, you could also have, I don't want to say a crappy system, but a not so high end system, but it's installed and it's installed thoughtfully and it was well designed and it could perform very well, know?
Yeah.
So it's like, gosh, I don't know. I don't see zone dampers as being all that bad as long as it's designed properly.
Well, right. And in your case, I think that makes a lot of sense. If you got 2 or 3 bedrooms, like you're not trying to take a whole house and split it. I think kind of paring down your zones as much as you can makes a lot of sense.
Yeah.
Okay.
So
so we talked about kind of the baseline of this kind of ideal system, or we're going to call it the TEL system. Let's talk about some other layers to that. And so, humidification, ERVs. What's kind of that next? Okay, if you've got this, zone system, multi-speed, what's the next thing that I can add it to get my bang for my buck?
So, the next layer is dehumidification, especially for our climate. So the byproduct of air conditioning is dehumidification, but that's not its primary purpose. So it will take care of some of that, but it's not its primary focus. That's where these dehus come in, and so that's their primary focus. They're purpose built to dehumidify this house, and if we're talking about a foamed house, they're really necessary. Especially if you're talking VRF or multi-speed. These VRFs aren't great on latent load. They're really good on sensible load. And latent load being humidity and taking the moisture out.
Yeah.
And that's just a product of them ramping a lot. So like how you dehumidify is you have a really cold coil and a really low fan speed. And so it just gives the water in the air time to actually condense onto the coil.
Okay. Huh.
And so whenever these VRFs are running low, the coils aren't super cold. The fan speeds are lower, but it just doesn't allow for that dehumidification like it would on like an old like traditional system.
Yeah.
So having these dehus are super necessary.
Yeah.
Agreed.
As far as dehumidification goes, I think you have to have them.
That's what I was gonna say. It's like, man, if in this climate, as humid as it is, it's like that has to be standard across the board. It's like, to me, I don't even care what type of system you put in, as long as it has a dehumidifier. Like, I think you're set up for success there. But
true, and going back to like a proper install too, like that's really going to help it. So ideally, the manufacturers want dedicated return and supply for all of these dehus.
Right.
Of course, nobody wants to do that because these dehus pump out hot, dry air, and so nobody wants a hot spot in their home, and so that's why you'll put it into the supply side of these AC systems, so it kind of mixes. But really, you want dedicated to really make sure that this thing works.
Wow.
But there's ways to do it to where you don't have to do that. But anyway,
That's really interesting.
Talking about this perfect system, there's really 3 things that you have to hit. It's thermal comfort, dehumidification, and then indoor air quality too. So I think taking care of like, okay, we're gonna do this VRF system, this VRF heat pump. We've got our dehu that's properly sized and the ductwork is done right, and then it's on to, okay, how do we ventilate our space?
Yeah, good.
And there's a bunch of different options with that too.
Yeah.
Well, let's get into it. I mean, especially nowadays as people build tighter and tighter homes, especially customs, it becomes more and more important to bring in outside air. Used to, your home was leaky enough where it didn't even matter, right? Because all that outside air was getting in somehow, either through the walls or through the windows and doors. Like you didn't need to worry about it. But now, because we build so tight, we have to mechanically introduce that outside air. So what are some strategies for that?
So, talking about, necessary, something that you're going to be very happy with for years is we've got our VRF, we've got our dehu, but you make it a ventilating dehu. So there's some ASHRAE is like one of the governing bodies that kind of put out all of these, I can't think of the word, but they've standards.
Yeah.
And so they've got standards of like how much fresh air you need to introduce based on, house size and occupants and bedrooms and all that. And so usually how it's handled with a ventilating dehu is, the fresh air is run through the dehu and uses the dehu fan to introduce all of this fresh air. And then it's based on time per hour. So it'll be 10, 20, 30 minutes per hour, depending on all of these different factors. That's it. And so it's more diluting the air rather than like exchanging it. But that's kind of the standard if you just want an AC system and a dehu, just make sure you have it ventilating so that you can have your indoor air quality. So
and if you're adding dehumidifier to a house, or dehumidifiers, what's the cost, we'll say, on a per zone basis? From what I remember, $1,000 or something. It's not like crazy high, but I could be wrong on that. I don't want to.
Well, it's a little more than that.
Yeah.
Not to get into specifics, but if it's new construction, depending on who's doing it and what dehu they're putting in. We put in ultra air, and so 70H is your smallest one that you'll get. And that's 70 pints per day, I think.
Oh wow.
It could be anywhere from 4,000 to 8,000, kind of depending on what you're looking at. So, but in the long run,
you need one of the. I guess it depends on how big the zones are.
Right, you can increase in size
because you can,
So you could be you could have like a 70 or a 100 or a 125, and it's just more capacity, right? And so, it just depends on size. I think the manufacturers have recommended like square footage that they have for each size, right?
Yeah.
And so, but of course, with all these engineered projects, like, they're already thinking about that.
Totally.
Sure. Maybe have their own standards on how big it needs to be.
Helping bring all that in.
That's it. So
that's cool.
What about, did we touch on ERVs?
I don't think so.
What are your thoughts on ERVs?
So I think they're great. I think for, if you want the highest end system, you have your VRF, you have your dehu, and then you have your ERV that handles your ventilation. So ERV is an energy recovery ventilator. So what an ERV does is, unlike a ventilating dehu that just dilutes the air, just brings in fresh air, an ERV will actually extract air out of your home and then bring in air at the same time. And the goal with one is to be balanced. However many CFM you're extracting is what you're bringing in too. And so the energy recovery part of that is that in an ERV there's a core where both of these airflows pass, and so you're trying to recover all that energy you used to cool this space and take hot humid air and at least try to cool it down, try to recover some of that energy that your unit used in order to cool it in the first place. And I think they're great. I think like I said, I think your highest end systems have them. And they do their job really well.
Are they supposed to like reduce the demand on the system? I've never really fully understood their purpose, because I get it. You're kind of pre-cooling the outside air as it comes in. So I guess is the theory that, well, now your unit has to work less hard because you're not cooling all that hot humid air.
Right. And so like, I guess comparing it to a ventilating dehu, that dehu's not cooling it whatsoever. So if it's 100 degrees outside, then it's just bringing in that hot air, that 100-degree air. And so so like a ERV, on top of trying to save energy is also, it'll make your system. It should make your system run less. Not saying.
It seems like this is one of those things, in my opinion, that like ERVs are just kind of a fad, in my opinion, because it's like, okay, your unit might not work as hard, but you're also consuming energy in order to do that, right?
Well, true enough. But I think just the energy cost difference, like you're running 2 little fans on an ERV as opposed to running your compressor in your fan, and
it's a smaller fan,
right? And so it really should use less energy than like running your whole system. But like I can see, they are a big cost.
Yeah.
I don't think they're necessary on every system.
They're great to have, but not necessary.
That's it.
Okay.
So
if we're putting it in tiers, it sounds like it's definitely
it's the tippy top.
Beyond dehu, your humidification system is more important in our climate than
agreed.
Energy recovery
Definitely.
That can make a huge difference in comfort. Is just the humidity level alone.
Definitely.
Yeah.
I mean, like 74 and humid feels a lot different than 74 and dry, right? So it's just like definitely. And so like that's what we always say. It's like if you have to choose, get the dehu because at least you'll be trying to dry. So
that's awesome.
Well, the last thing I wanted to get into was this was makeup air, right? And what are some strategies with that? So Michael, can you tell us what is a makeup air? What does that mean?
Yeah, you had touched on this briefly earlier about balancing the system. So their ideal system, like whenever you go to open a door, your front door, for example, you don't want there to be back pressure on that thing. So it's difficult to pull. And vice versa, where if you're closing it, it's slamming. That's one of the ways that you can tell if a system is balanced or not.
Very good.
And so when you're talking about pressure within a house, what are some of the times that really changes the pressure in your house? Well, one of those is in the kitchen. It's your vent hood. And if you have a large, kitchen setup, you've got a large vent hood. And what's that doing? That's sucking air.
It's a vacuum.
Well, smoke. Yeah, it's a vacuum.
Yeah.
You just put a giant vacuum in your house.
Yeah.
So,
I mean, we've had, we've had ventilation systems in a kitchen. I mean, it pulls out 2,400 CFM, pretty large, substantial volumes of air that are being pulled.
Like a commercial kitchen.
Yeah, it's like a commercial setup.
And
like, and some I think even bigger than that.
Yeah.
And so you look at it, you're pulling out tons of air, and now you have this. Basically, you've created a vacuum in your home. So a makeup air is basically designed to balance that vacuum that you've created.
Exactly.
Right. So walk us through, what are some things that work and what are some things that don't work when in regards to makeup air?
Right. So, usually, depending on what the engineer calls for, or, I mean, the hood size is really what determines most of it. You know, there's you can have a passive one. So only a damper opens. It's not fan assisted or anything, so it's just like whenever that hood kicks on, a damper to the outside opens and it just brings in air as it's being pulled out. There's also active ones where there's actually a fan on the system that's actually trying to match and bring in as much CFM as what's being pulled out. And those are only necessary because these hoods are getting bigger and bigger, and people are putting in these crazy ranges, which necessary or not, when it comes to cooking, whatever.
All that aside,
Well, you got vent hoods, but then in some cases we've actually had fireplaces that do the same thing. Where you have a a fan that sits on your roof that drafts a lot of that heat and smoke out. And so you have to have a makeup air for that.
Well, and so one of our projects, it was like one of the first makeup air systems that we did for a fireplace. This was a foamed house. This guy wanted his fireplace, which, even though he had a great VRF system, he still wanted to have a wood burning, which is cool. But it was something happened with one of the dampers. It was DOA and nobody knew, and so he turned on his fireplace and smoke started backflowing into his house, and so I guess bringing up that story just shows how necessary they are on a foamed house with a fireplace. And so usually how we handle that is we'll have the active ones. We'll have an active fan tech system with like an actual fan, and we'll put it on a dial. And these are variable speed fans, and so you can crank it up or down. Usually a homeowner's not going to want to be able to mess with that, so I just tell them, just crank it up. Let's just make sure no smoke is backfilling. You know, so. But in those instances, I think it is necessary. I mean, definitely for the fireplace, right, and then for kitchen hoods too, just to make sure all that CFM gets sucked out, and all the smells and everything.
And do you like that air to be cooled, or is it and brought into the HVAC system as a way to be distributed, or do you like it dumped as close to the source of suction or vacuum as possible?
Yeah, so and that's one of the big things is so usually what will be engineered is that it comes through the toe kick of like the stove or whatever it is, and it's just drafting right there, and it's not being pulled across the space. What some people would like to do is put it in a return across the kitchen, and now you're drafting all this cold or hot or humid air across the whole space. And so yes, having it as close to the source as possible is best practice.
Interesting.
I have a question. Could you install a ERV on a makeup air system so that as you're bringing in, right, you turn on your vent hood and this thing kicks on automatically, so you're bringing in fresh air right to the source, but it's pre-cooled basically, or preheated?
So let me think through that.
Yeah.
I mean, so
it's an interesting question.
Yeah, that is interesting. Well, like you would have to set up the ERV in a way to where it's bringing in more air than it's extracting at that point, right? Because it's already balanced, and now you're turning on this other vacuum, and now you're trying to make up for that vacuum.
I'm talking like theoretically, this is a separate ERV from
just specifically
for the makeup air system.
You know,
because we got money to throw at everything. So
I guess. I guess this is a good question, because I have seen projects where the makeup air needs to be a substantial size because you've got this really large kitchen hood. It's a prep kitchen, and there's gonna be commercial things going on, or whatever the situation is. And then that becomes a question, because you're bringing in a lot of makeup air, and you've got
for sure.
And part of the problem is that air, as it's moving, you want it as close to the source, dump as close to the source as you can of the vacuum, but you've got to bring that air into the house uncooled, and so now you got to be really careful that pipe is not condensing within the house somewhere.
That's true.
That's a good point.
Because the air is going to change temperature, from where the exterior wall is to, your kitchen, and so, that whole system, so I don't. It's just really counterintuitive to me, because you're building a really tight house, and then you're puncturing a giant hole. I mean, it's kind of like a fireplace. You're puncturing a giant hole in it, and how does that air interact with everything around it? It's kind of interesting.
Yeah.
Well, yeah.
ERV could be a good solution.
Well, so the only thing about that is, and so this is, people have used ERVs for their bathroom exhaust fans too, and so and so that's usually that's what we'll see, depending on who engineered it, is they'll replace all of the exhaust fans in the bathrooms with these ERVs.
Interesting.
But they're running all the time. They're designed to only run at like 20 CFM per bathroom, and they're running all the time. And so taking that and moving it over to this hood vent situation, I would think that's how you would handle it, is like if you were to do that. This thing would have to run all the time, and you wouldn't even worry about hitting a fan. But it's, these ERVs, the ones that we deal with in like residential, like the highest CFM is like 150, 200. And you're talking about these ranges that are 2,400.
Yeah.
You know, I mean,
so that's gonna be that ERV would need to be
massive,
cranking.
And like
really.
I mean, there are boost modes on them, so like you know they'll run continuously, and they'll do 75 CFM always, and then you know we had a project where in the primary they had a steam shower, and the engineer knew about it, but when they had their questionnaire with the client was like, oh, we're only going to use the steam shower once a day, like the wife's going to use it, the husband doesn't want to use it, the kids don't. Well, it turns out the whole family started using it. And so you had the steam shower for 3 hours in the morning, right? Going, and just like this ERV couldn't handle it. And so
interesting.
And so at the time, we didn't put a boost switch in for it, but then we found a way to do it, and being able to crank it up all the way really helped. So
sweet.
I mean, there's, you know, anyway, again, ERVs are like tippy top. They're, you know, they can be pretty crazy too. But I think, you know, instead of just diluting the air, being able to extract it and then bring in the fresh air is the best way to do it. I mean, any CO2 buildup you have or any kind of VOC, you get it out and then you replace it with something fresh.
Yeah.
Which I think is the way to do it.
Yeah.
Are you starting to see, you know, people request, you know, we mentioned like water to air systems earlier, or even geothermal, which, you know, you don't really hear about geothermal a lot, but I mean, I guess you're starting to see water to air systems. So, I mean, do you have any experience with those, or they're starting to hit the market, or?
So, I just went to like a showcase that Mitsubishi had for their brand of air to water, and it's called EcoDan. And they were just kind of showing us all the different possibilities that you could have with this air to water system. And I think it's really cool. It's just depending on company, you know, like you almost have to be a plumber now too, because you're running all this PEX that gets moved around, and like some guys are set up for that, and I think it makes a lot of sense for them.
Yeah.
You know, whenever I was going through it, I was almost like, okay, we're going to do the outdoor, we're going to do the indoor piece, we'll do the holding tank, and then the plumber takes over.
Yeah.
You know? And it's just like, y'all can worry about the house.
Yeah.
And we'll just worry about those pieces in between. I think it's really valuable. It's just really expensive right now, too.
Yeah. So air to water, that's basically... water is your refrigerant, right? Like you're either heating or cooling the water, and the water is running through a network of pipes, and air is moving past those coils or pipes, if you will, and either heating or cooling with the water.
So like when you're talking about like a forced air system on air to water, yes, like you can think of it as just like instead of refrigerant, you have water. But what's cool about air to water is all the possibilities you have too. Like you could have radiant floors. That not only heat, they cool. You could you could do, you know, domestic hot water too, and, you know, you could heat up your hot water tank with the heat from your house.
Wow.
Cool your house and heat up your water, right? So it's just like conceptually it's really cool. As far as practicality, like I don't know where that sits on like the efficiency train. Like I'm sure it's really efficient. That's why everybody wants to do it. But it's just like in practice, you know, we haven't done one, so like we don't have a ton of experience with it. But you still have a refrigerant circuit on that system. It's just not your primary way of like physically cooling a space or heating water.
I gotcha.
So
running more water pipes in a house is scary.
Yeah,
to me.
I was
kind of
just gonna say
terrifying.
that.
You know, not being plumbers and having to deal with water. You know, water is always scary for us. We have to make sure our drains are good, make sure we have float switches and all that. And they're like, and they're like, okay, just run more water pipes. I'm like,
less water pipes, less water pipes.
Yeah, and pressurized too. And I'm like, okay.
And now you're talking about, you know, you can heat and cool your floors with the water. Well, it's like, that sounds cool, but if you're cooling your floor, is it going to get cold enough for condensation to occur?
So
like now we're really.
I think what the difference is that
trouble.
The temperature of the water itself isn't that cold. It's not as cold as you think it needs to be. So like surfaces shouldn't reach dew point.
Okay.
And actually can condense, and that's what's really cool about it too. Apparently, is that like the temperatures you're actually working with aren't as cold as you would
crazy.
think.
Gotcha.
Right.
It's good to know.
Well, you got anything on makeup errors you want to talk about, or you good?
That was fantastic.
Yeah, no, I think
really
that was
appreciate your time, Tel.
we touched on a lot of different stuff. I mean, we really ran the gambit on HVAC systems, but
and there's always more too, though. But
and
I think high level, this was great. Definitely.
No, and I appreciate your expertise, your insight. You know, you've really worn a lot of hats and gotten to handle, not only the install but the commissioning of the units and the servicing and the pricing, and like you've done a lot and seen it all. So, you really bring a valuable insight to this conversation. So, Tel, I appreciate you coming on.
Well, thanks, guys. Thanks for the invite. This was fun.
Yeah,
for sure.
Awesome. We'll do it again sometime.
Until next time.
All right, appreciate it.